Insulation resistance test or Megger test. So why we have to do this insulation resistance test? The insulation will degrade due to moisture content, due to aging factor, due to over application of use, due to mechanical and electrical stress, and due to dust particles. So these are the reasons the insulation resistance may get degraded. So if the insulation resistance fails, then the equipment will be damaged. So to avoid this periodically, regularly, we must test the insulation resistance. So that is done by the instrument which is called as the Megger. So here we have two types. So one is analog meter and one is digital meter. The analog meter is a hand-driven permanent magnet DC generator, and the digital meter is battery-operated digital meter. This is two types of Megger. So this hand-driven permanent magnet DC generator analog meter, a two-person is required for a perfect reading. So one will be driving the hand-driving crankshaft, another would be placing the probe and measuring the resistance value. Also, the analog is quite difficult to measure the exact accurate value. And as compared to the battery operated digital meter, battery operated will get a accuracy of value. Also, an individual can measure by using this battery operated digital meter. So this is the advantage and disadvantages of the two meters. And the next slide, Megger is used to measure the high resistance of the order of mega ohms. So you may have a doubt, why can't we use a multimeter? Why do we use a Megger? Megger is used to measure insulation resistance. Multimeter is used to measure the resistance value, as well as it can measure voltage and current also. Both operating as a deflecting coil operation. But what is the difference is multimeter can give voltage for a less rating of the electrical equipment as compared to the Megger. Megger is used to measure in mega ohms. So if a Megger is 500 voltage of Megger is used, that can measure the equipment range up to 440 voltages. If we go beyond 500 voltages, 1000 volt, 2500, 5000 volt, that is used to measure the high voltage electrical systems. So when the voltage increases, the insulation resistance value also increases. So according to that, the Megger is used to measure the high resistance value in the order of mega ohms. The device is used to testing IR values of cable and condition of the winding inside the equipments like motor, generator, transformers. It can measure the insulation resistance of cable, also windings, all electrical equipment windings, motor, generator, transformers will be measured by the instrument Megger. If the measured insulation value is weak, then chances of damages to equipment due to heavy current flowing. So when the insulation failure occurs, heavy current will flow and that will damage the equipment. Whenever the electrical equipment voltage is raised, the insulation resistance value will be also raised. So that's what it is said in the next point. So whether it is 1000 voltages, 2000 voltage or 5000 voltage, for a high voltage electrical system, we'll use Megger value to be 1000 and 5000. This is for high voltage electrical system, but we cannot make it in a hand driving generator. We have to select battery operated or power operated Megger. One precaution for this is the probes should not be touched because it is direct current. If it is more than 500 voltage, it is very dangerous. So the probe should not be touched. That is a precaution. And the second thing is we can say that The insulation resistance which is going to be measured should not be of a very low voltage range. That will damage the system. Whenever we do the winding measurement in generators, we used to disconnect the diodes, power diodes. So that because the diodes are working by a small voltages, so that should not get damaged. So we will remove the electronics equipments. So this is all the precautions we can say for the measurement of the insulation resistance. Connect the measuring probe in the Megger port. One port is for line and the other is ground of the Megger. We are going to connect the probe in the Megger. There is a guard ring. It's provided to shunt leakage current over the test terminal or within the instrument. If you have any leakage of current, that leakage current will be bypassed through this guard ring. That should not disturb the measurement. So if any dust or paint particle, dirt particles present in the earth terminals, it has to be removed. So moving to the next slide. So this what they are mentioning as a guard ring. The guard ring that is used to dissipate the leakage current, which is formed in the terminals or which is formed in the equipment. The leakage current, it has to be dissipated to the ground. So the construction and working principle of the Megger. So what is the construction? What are the parts which is present in the Megger? DC generator is present between a permanent magnet, and the DC generator is having a hand driven instrument that is used to drive the DC generator. The armature is going to produce the voltage. So there will be a clutch. The clutch is used to give the predetermined value of speed. The clutch is going to give a constant speed. So when the generator is rotating at a constant speed, the voltage produced at the generator will be also at a constant value. If it is a constant value, then there will not be error in our readings. So if there is a fluctuation of the speed, and there will be a change of the voltage also. So in that condition, error may occur. So the clutch is provided so that the generator is going to produce a constant voltage at a constant speed. So other construction details, we have two coils. One is called as the current coil. This is called as the current coil. The current coil is also called as deflecting coil because this is connected to the deflecting coil. This deflection is going to move the pointer. So this is also called as deflecting coil. Normally the current coil will be connected to the series to the generator. Normally we connect the current coil in series and voltage coil in parallel condition. So same thing they have done here. The current coil is connected series to the generator, and this is also called as the deflecting coil. And one more coil is present. This is called as the pressure coil. It can be called as a pressure coil. It can be called as a control coil. This can be called as a potential coil. So the voltage coil will be always across the line, so parallel to the generator. So current coil should be connected in all circuits. It should be connected in series. And voltage has to be connected parallel to the circuit. Same way the connection construction is done here. And there is a current limiting resistor, R and R dash. That is a current limiting resistor to protect the coils. So the two coils are placed in the magnets. So under what principle the Megger is working is, it works on the principle of electromagnetic field. So when a current carrying coil is placed under the magnetic field, two strong magnets, so between that the coil is carrying the current. So it will experience a force. That force will drive a torque. That torque will make the deflecting to make the pointer move in the meter reading. So it works by the electromagnetic field principle. When a current carrying coil is placed under the magnetic field, it experiences the force. The force will drive the torque, and that is used to deflect the pointer. Normally, our voltage coil, the pressure coil, will be always in energized condition, and the current coil will be producing the torque. Then the deflection will be present. So according to that, the deflection will be present. We have three conditions, main conditions how to measure. So before connecting for the testing, what we must do is the two leads should be touched together. And the generator crank is rotated slowly. So the pointer deflects zero resistance. So the resistance under the test to be connected is between L and E. So now after checking this, before connecting the leads, we have to make the two leads to be touched together, and we have to see what is happening. The generator will be rotated slowly and the pointer will deflect to the zero resistance. Then the first condition is under open terminals. The test terminals is kept at open. So whenever there is an open, there will be a very high resistance that we can say it as an infinity. Now the crank handle is driven. DC generator is rotated. The armature is going to produce 500 voltage. The voltage will be flowing through the potential coil. The coil will be always in energized condition, as we have already said, but there will not be any current in the current coil because it is in open circuited. It is open terminals, no testing. It is in open terminal. In open circuit, no flow of current. So according to our Ohm's law, R is equal to V by I. R is equal to V by I. So our I value is very less. I value is not flown in the current coil. No current in the current coil. So the deflecting torque is not moving. The pointer will be resting at the point of infinity. The pointer will rest at the point of infinity. So that is the condition for the open terminals. Next, short terminals. The testing terminals are shorted. So now what will happen? The generator is operated with a constant speed. So it is going to produce a constant voltage that will flow through the current coil. Less current through the potential coil. So now what will happen? The resultant torque will make the pointer to deflect zero. So now the resultant torque is producing the pointer to be deflecting to the zero position. So this is what the second condition. And third is an unknown resistance is connected in the test terminal. Current flows in both the coil. Now the required amount of current, actual amount of current will flow through both the coil. This coil here, or here one coil is there. So this is a control coil or potential coil or a pressure coil. So here one coil is there. So this is called a deflection coil or a current coil. So both the coil will be producing the torque. Both the coil flow of current is there, so it is producing the torque. That torque will deflect, and that will be in between your 0 and infinity. And that will be according to the current ratio. Both the current ratio. According to the current ratio, the pointer will show. So this is the value of the unknown resistance, what we are going to be measured. For example, if you want to measure the winding of a motor, one point we can keep at the winding and the other can be to the body of the equipment. And when we rotate the hand driven generator, we can measure what is the insulation resistance of a motor. Same way we have to do it for cable and wherever the windings are present. So periodically we have to measure the insulation resistance of an equipment. So if the insulation resistance value is good, then the device will not get damaged. Otherwise, we have to improve the insulation resistance value. Thank you for listening.